Hello everybody. So I'd like to show you these two problems from MyMathLab. I'll do this one first and then this one, and they look different, but I'll work both of them by the quotient rule. Okay, so let me show you how. So with this first one, it looks like you would use the product rule, I think. The reason I say that is because this original function y is the product of two functions. 3t minus 1 is the first one. That's a function. That's a formula all by itself. Times this other one, 2t minus 4 to the negative 1 power. That's a function. That's a formula all by itself. It's the product of two functions. So it seems like we would use the product rule, but I'll explain why I don't think that's the way to go. Okay. Before I do that, notice about this that this dy over dt symbol I haven't used yet. All right, at least not in my videos. I haven't showed you what that is yet. Okay, so let me tell you just a little bit about that. It's something that we'll cover in more detail later. So the situation here is that y is the original function. And what dy over dt means is the derivative of some function where y is a function of t. Okay? This symbol for the derivative is called Leibniz notation. Like I said, we'll learn more about that later. But for now, let's say that just means the derivative. It just means that we have this function and we're looking for the derivative, okay? With whatever rules are appropriate. In general, real quick, I'll say that if you see this notation in some other context, say dy over dx, it just stands for the derivative of some function where y is the dependent variable and x is the independent variable. Okay? dy over dx means there's a function out there, y is the dependent variable and x is the independent variable. Okay? Find the derivative of that with whatever rules are applicable. So that's called Leibniz notation. It's something we'll use a lot more as we go throughout the semester. Real quick, I'm using these terms dependent and independent variables. All a function is you put a number in, you get a number back out. The input, the number you put in, is the independent variable, and the output, the number you get back out, is the dependent variable. All right, so that's how I'm using those terms. So anyway, so back to this. I don't think that the way to go with this one is to use the product rule, because in order to use the product rule, I'd have to know what the derivative of 2t minus 4 to the negative 1 power is, because that's that second function. That's the function you're multiplying this one by. So because we haven't learned that, that's not the way to go right now. And I would say even once you learn the rule for the derivative of this, it's still easier to work it the way that I'm about to show you. Okay, so here's what we'll do. I'll just rewrite that as a quotient. It's easy to do. You know, this other term here has an exponent of negative 1. That means I can send it under the bar and its exponent becomes 1. That means it just becomes 2t minus 4. Okay, so I can rewrite this function as a quotient. It's not hard to do, and it makes this way easier. We do a lot of rewriting in calculus. We might be given a function that looks a certain way, but the rules as we have them don't apply very well to it. So we often rewrite things before we even start working on them. Okay, so I was given this function. I've rewritten it now like this. At this point, the rule that would apply to it is the quotient rule. Okay, because y is one function divided by another. Okay, so I'll say f is the function on top, g is the one on the bottom. Okay, so here's what the quotient rule tells us the derivative is. F prime g minus g prime f over g squared. That's the quotient rule. F prime, the derivative of 3t minus 1 is just 3. G, okay, minus g prime, the derivative of 2t minus 4 is just 2. Then times 3t minus 1. And then over g squared. So there's your derivative. This first part's algebra. Then me going from y to dy over dt is calculus. Okay. All right. Specifically, calculus, finding the derivative with the quotient rule. So anyway, from here, what would we do? I guess like, in a sense, like this is our answer. This is the derivative. I used the rule correctly. There's no mistakes in this. It's dy over dt. It's the derivative. But what we often do in addition to that is we simplify things. The answer often can be much simpler than our first step reveals it to be. Okay? So I will simplify this. I'll do whatever I can to reduce it, to combine numbers, to cancel, like whatever it is. So what I could do to simplify this is distribute the 3 and the negative 2. If I do that, I get 6t minus 12 here, minus 6t plus 2 here. There's some obvious like terms to combine. 6t minus 6t cancels. Negative 12 plus 2 is negative 10. So it's negative 10 over 2t minus 4 squared. And we're done. That's the derivative. See how much simpler it is than our first step gave the impression it would be? Okay, so expect to use your rule to find the derivative and then do a little simplifying after that. That's the way it will work most of the time. And that's the answer that you see here. The negative's out front, but it means the same thing, right? A negative divided by positive is a negative. All right, so we put that dash, that negative sign right out front if you want to. All right, so that's this one. Let's look at this one. It says find the derivative of the following function considering k is some unspecified constant. So I'm looking at this and I see that x is a variable and it said that k was a constant. All right. Okay, so I got a variable in x, I got a constant in k, and there's my derivative. Now, let's see. Here's my function. I'll do a little analyzing of it before I show you my work. This part of it, I would use the quotient rule. X is a variable. It's the independent variable. I get one function divided by another. Plus, and then this is just a constant. Okay? If k is a constant, if k is some fixed number, then k squared is also a constant. K squared is also some fixed number. Remember, the rules in calculus apply differently depending on whether you're dealing with a constant or a variable. So for this first term, I'll use the quotient rule. There's the derivative of that top function times the one on the bottom minus the derivative of the bottom function is 1 times that top function, x plus k. So this is the quotient rule as we would use it every time. Divide that by this bottom function squared. So there's your derivative of the first term. From there, I would carry down the plus, and then this part would be the derivative of that second term, but that second term is just a constant. The derivative of any constant term is 0, no matter what it is. If this constant was 7, its derivative would be 0. If this constant is k squared, where k is a constant, right, then its derivative is still 0. Okay, so now, just like I said over in this problem, my first step is calculus. My first step is finding the derivative. The steps after that are just simplifying it. So I might wonder, can I combine or cancel or otherwise reduce anything that I see here? I'll distribute the 1, I'll distribute the negative 1. I'll get this, the x's cancel, the k's can be added, and there you have it, your final answer, negative 2k over x minus k squared. Okay, so that gives me a look at two similar but different questions, similar in the respect that I use the quotient rule for both of them, but I think this one would surprise you, especially as you're learning calculus for the first time and you learn the product rule, you learn the quotient rule, you see something like this and you think product, and it does look like a product, but I show you this just so you see that that might not always be the easiest way to go. Consider if there's any simple rewrite of the original function that might be a little bit easier to work with.